Hey ladies, so today we're doing section 9.3. Here we're going to be connecting graphs and rational equations. Or really what this essentially is going to be is that we're going to be solving rational equations, and surprise, surprise, it's hopefully nothing new here, but we're going to be doing it using two different methods. We're going to be solving rational equations algebraically and by graphing. So you guys have already seen these methods before these past couple units, or sections, or chapters, sorry. And so hopefully, you know, this hopefully is just another review, and we're just going to be using different types of functions instead of what we would have used before. Alright. And so just as a note here is this is our last lesson for the unit. It is a short unit. The rest of them will be short as well, so just keep in mind tomorrow will be assignment, then it'll be review, and then test. So pretty short unit, so just keep that in mind. So once when you're finished this lesson here, okay? So first of all, we're going to talk about solving rational equations algebraically. So I'm just going to repeat the steps. Hopefully this will come as no surprise to you guys. This one here, I actually just listed the steps. So, you know, maybe whether or not this will be a snooze fest lesson, or hopefully it'll just be, you guys are just so excited because it's going to be so easy because you guys have already done this. Either way, just bear with me, and we'll work through this lesson together, okay? Alright, so first of all, we're going to talk about solving rational equations algebraically. So what solving algebraically will do is it'll determine the exact solution and any extraneous roots. And so our first step there, we need to equate to 0 and list the restrictions. So first of all, what that means is look for any non-permissible values and list what the restrictions are. And then our next one there is we're going to factor the numerator and denominator fully, and that's if possible. We saw last video that we had this crazy looking quadratic graph, and so we couldn't actually cancel anything out. So, but still factor it if you can, and who knows, maybe there are some values that we can cancel out or simplify it to. Okay. Then what we're going to do is we're going to multiply each term by the lowest common denominator, which that step will eliminate fractions. Then we'll solve for x, and then check your solutions against the restriction, and then substitute it into the original equation. So that part there is verifying your solution. So first check the restriction. If it meets the restriction, then substitute it into the original equation, and make sure that your left side is equal to your right side. Alright, so pretty much the only new step here is that we're going to be multiplying by our LCD, because we're dealing with fractions now. That's our rational equation. So we want to eliminate fractions. Fractions are, I like to say, ugly. I don't like to deal with fractions, so eliminate it by multiplying by the lowest common denominator. Or if you guys can simplify it too, you guys can cross multiply and divide. Do whatever kind of process you guys work best with. I'll show you using these steps, and then if you guys want to try it a different way, it's absolutely fine. There's multiple ways to solve these, but you should get to the same answer no matter which method you use, okay? Moving on down to number 2 here, we're going to be solving rational equations by graphing. And so we've already seen there's two different types of methods. The first one is to use a system of two functions. So we graph each side of the equation on the same set of axes. And here the solutions will be the x-coordinates or any points of intersection. So I'm going to give you guys an example. So say we had 16 over x plus 6 is equal to 4 minus x. Sure. You know, I just pulled down out of my head. So when it says to graph each side, so remember you're going to graph your left side as y is equal to 16 over x plus 6. And then you'd graph your right side. So you'd have y is equal to 4 minus x. And then what would happen is you're going to find your invariant points, or those points of intersection, so the points that they have common in there, and those will be your solutions. And the second way we could solve by graphing is to use a single function. So what we would do is rearrange the equation so that one side is equal to 0, then graph that function, and then your solution will be the x-intercepts, or where y is equal to 0. So it'll cross wherever it intersects with that x-axis. So say we had some sort of parabola here, it'd be your x intercepts there, or where y is equal to 0. Okay? So let's use that same example there. So here we had 16 over x plus 6 is equal to 4 minus x. If we move it all to one side, we would have, and I'm going to set this one equal to 0. My graphing calculator, I need to have it y is equal to. If your graphing calculator will graph 0 is equal to, say, 16 over x minus 4 plus x. That's absolutely fine. But what I need to do is, from my graphing calculator, I need to put it in as y is equal to. You'll have 16 over x plus 6, and move everything over to one side, and it actually doesn't matter which side you move it to. So in this case, I'm going to move my 4 and negative x over, so we have negative 4 plus x. And then from here, you're going to look at when y is equal to 0, or when it crosses that x-axis, okay? So you guys have seen these methods before, which is why I didn't go into a huge, super long explanation about these. So we're going to jump into some examples and work through it that way. And one thing that, since we have looked at these methods before, try pausing the video, try doing them on your own, and see if what we do matches up. And but if not, I will go through the solution now, and we'll compare solutions, okay? All right. So this first example here, we have solve x divided by x minus 1 minus 2x is equal to x plus 1 over 2x minus 2. So we need to do that both algebraically and graphically. And one thing that'll be really nice is if you do this both by both using algebra and by graphing, you will find that you have the exact same solutions. So that's one really good way to check it. So say I give you the option of solving. It's always good to do it algebraically, and then you can verify it by graphing. And then if you have the exact same solutions for both, then you know that your work is right. Or it could go vice versa. If you graph it one way, you could graph it the other way. Or you could also verify it by using algebra. But either way, you should get the same answer, and it's a good way to check your solutions and make sure that they're all good, okay? So for the first one here, we're going to graph. And by this point, hopefully we're good with our graphing. So you guys are more than welcome to use your graphing calculator. I will write out a table of values just so you guys can compare. And for this example here, I'm going to move everything to one side. If you wanted to, you could graph it independently. You should get the same solution. It'll just look a little bit differently, okay? So here I'm going to move everything to one side. And so what we would have is y is equal to, it'd be x over x minus 1 minus 2x. Then we're going to subtract this whole term to get it to the other side. So you have subtract x plus 1 over 2x minus 2. So this here function is what I'm going to put into my graphing calculator. And so this is a lot of work. So if you guys want to, you're more than welcome to use your graphing calculator. If not, try doing it by hand if you like. But it's a lot of work. And as long as you guys know what you're doing, we've had lots of practice with graphing. I have absolutely no problem with you guys using a graphing calculator, okay? So I'm going to scroll on down just a little bit. I'll give you some values that I came up with in my graphing calculator. So we have x and y. And remember, you always start with your non-permissible value. So here, you're always going to be looking at your denominators here. So we have x minus 1 is equal to 0. So our first one there is at x is equal to 1. And then we have another denominator here. So we have 2x minus 2 is equal to 0. And there we can move it all to, solve for x. We'd have 2x is equal to 2. Divide by 2, and we get x is equal to 1. So that's actually really nice. They have the same non-permissible value, so we don't have to do a whole lot of work, but one thing that we will do is we'll graph quite a few above, quite a few below, just to make sure we see what's actually going on, okay? So remember, start with your non-permissible value in the middle there. And this one, if you guys, this one here will be undefined. And actually what we'll notice there is that if we were to simplify this, this would be a whole, which you guys will see in your graphing calculator, okay? And so then we're going to graph a few below. So it'd be 0, -1, -2. If you guys pull out your graphing calculators, you should be able to get your table values. So some values that you should see: for 0, we'd have 0.5. For -1, we'd have 2.5. And for -2, we have 4.5 there. Okay. Now going above 1, so say we had 2 and 3. When x is equal to 2, we'd have -3.5. When 3 is x, we have y is equal to -5.5. So if you notice there, it actually, this follows the characteristics of a linear equation, which is very nice. That's what we like to see. They're a lot easier to graph. I really like linear equations, so this is awesome. So let's go ahead and plot this onto our graph. And so even though you guys are using your graphing calculators, it's always good to have it in your notes, so please make sure you write this into your notes, okay? And so first step here is to label your spacing. And our y values, we'll do the same way. So now that we've got that done, let's start graphing. So we had x is equal to -2, we're at 4.5. Approximately right there. Alright. Then we have -1 and 2.5. Then we had 0 and 0.5. Then when we had x was equal to 1, if you guys can't see this on your graph, or if it doesn't give you that value, you can plug it in. If you guys had a simplified version, or what you can do, leave it till last. We'll just skip over it, and we're already starting to see this line pattern. And what we'll do is we'll just fill in that hole afterwards, okay? So then x is equal to 1 is it's undefined, so we'll just leave that one as blank for now. Or if you guys can even see that pattern, it goes down, or you subtract 2. So it should be at 1 and -1.5, but if you guys can't see that, maybe let's just move on, then we'll kind of show you how abouts to figure out that it's a hole and what coordinate that would be, okay? So moving on, we had 2 and -3.5. Then we had 3 and 5.5. So I probably even could have gone, sorry, with the y values, just change it ever so slightly so that we could have, I guess, our 5.5 on the graph there, but that'll be fine there. And so what we can do from here is, let's create that straight line. And I'm going to use our shapes on our Word document, just so I can see this nice straight line. Alright, so if I do this one right here, let's try this out. I should have really done this in the first place, but I kind of forgot that this was a thing. And so let's create a straight line there. And from there, make sure you have your arrows at the end there. And what we can do here is, you guys hopefully use a pencil, so then what you guys can do there is draw a hole there. Erase that little line there, and you guys can draw a hole. And so that's if you guys can't see where that hole would be, but otherwise you guys could draw it like this and then pinpoint it. So at 1, you can see here that actually it perfectly lines up with -1.5. And if you guys notice that, going back to that table of values, you guys would see that it follows that pattern. You subtract 2 every time. So then in theory, this one here should be 0.5 subtract 2, so that should be at -1.5. So if you guys can't see this pattern in that table value, then you guys are more than welcome to draw it this way. So where you guys have that line and then create that hole. Okay. So just to quickly finish off this graphing solution, what we're going to do is, because we had everything to one side, we're going to find out where x is equal, or sorry, where y is equal to 0. So what is that x value? And if you look there, that looks like it's approximately, we could say x is approximately 0.25. It kind of looks like it's nicely between 0 and 0.5. So we could say that x is approximately 0.25. So now in the next video, we're going to solve it algebraically. And then for example number 2, we are going to, you're going to choose your own method, and I will do both. I'll do a couple solutions. You guys can just fast forward to whichever method you guys want to use, okay?